This video is going to be covering how to create tools in sheetcam. We pulled up sheetcam, and the first thing you want to look at is this menu up here for tools, and you want to create a new jet cutting tool, which is also a plasma cutting tool. Okay, so let's say you get these parameters generally from your plasma cutter manual. Depending on the particular model of plasma cutter, each plasma cutter cuts at a different height, at a different speed, and has different kerf widths in general. So normally what you're going to want to do is look at your manual, and it should have a set of parameters as far as different types of cuts, and they will have recommendations for your pierce delay, your pierce height, your cut height, and so forth. And this is where you get all this information to generate this tool from. So let's say we're going to be cutting some 1/8" mild steel. Okay, so I'm going to name this tool 1/8" steel. So quite often this button here is going to be automatically clicked. Generally you don't want to. I like to name you can have it automatically name the tools. I like to name them myself, so I have a better understanding of what I'm doing. So your plasma, it's going to be, the type's going to be plasma. Generally the tool number you can leave be, and there's one exception, I'll talk about that a little bit later. Your kerf width is going to be, you're going to find that in your plasma cutter's manual, and that may vary depending upon the amperage you have your plasma cutter set at, or the type of tips you're using. My particular plasma cutter is PowerMax 45. I know my kerf width is going to be 0.06, so I generally always leave it that way. Feed rate, I know from my experience that 1/8" cuts pretty good at 100 inches a minute at 45 amps with my plasma cutter. Now if I look in the manual, it'll tell me to cut at, I think it's right around 120 to 130 inches a minute. I can cut at that speed, but I find my cut quality is not quite as good, so I generally cut a little bit lower, and fine-tuning your settings for your cuts will be something that you're just going to have to you're going to come to as you get more time on the tool. So I don't need a pierce delay for this because it's only 1/8" material. Generally with most plasma cutters, you're not going to need a pierce delay on stuff under 1/4 inch thick. Mach has a somewhat of a built-in pierce delay, kind of a delay in the system that automatically delays a certain amount of time. So you're not gonna, a lot of times your manual will tell you, say, 0.02 seconds. Well, Mach really can't do a 0.20 delay. About the lowest it can go, I think, is a ½ a second. And so generally don't worry about it unless you're over 1/4 inch, and then that's something you're going to have to generally just kind of adjust and play with, and you'll be able to see if your plasma cutter is piercing the material before the machine starts to move. And that's what you're looking for, is it to pierce and then immediately start moving. So you want to find that window there. Your pierce height, all plasma cutters pierce at different heights in general. For mine in particular, I know it's 0.15. It's always 0.15. Some plasma cutters vary their pierce height depending on the amperage that they're running at and the tips you're using. Your plunge rate, like I said, that's the speed of how fast your z-axis is going to move from pierce height to cut height. I always leave it at 150 inches a minute because you want it to move as fast as possible. Your cut height, again, is going to be dependent on your plasma cutter, and it will be in your manual. Some vary it depending on the material, and the amperage and speeds. For my particular plasma cutter, a PowerMax 45, it's pretty much always at 0.06 inches, which is, it's pretty low. It's about the thickness of a nickel, and that's probably the key reason why torch height control is very important. Pause at the end of the cut. This will pause your plasma cutter at the very end of the cut. Usually, sometimes I'll use this on thicker materials, but I usually keep it a very short pause. I'll keep it like a half a second. Sometimes it's handy if you're cutting thick materials. You got to remember that your plasma cutter flame trails behind itself. So as the top of the flame reaches the end of the cut, the bottom of the flame is trailing behind it. So if the plasma cutter cuts off immediately, sometimes you can be left with a small amount of uncut material at the bottom of the cut. And so by creating slight pauses on thicker materials, like a half a second pause, you can give your flame enough time to catch up to itself and straighten out before the machine, before Mach turns off the plasma cutter. Don't make your pause too long, because then your plasma flame will run out of material before and basically lose its arc before Mach can turn off the torch. And generally you want your plasma cutter unit to turn the torch off rather than have it lose arc. It's better for your consumables. Your lead-in types, whether it's normal, ramp, or wiggle, generally you're going to be using the normal setting. Sometimes you can use the wiggle setting. If I were setting up like for instance, my machine really has a max capacity of around ½ inch, and that's pushing its capabilities. So if I were generating a tool for ½ inch, I would use a wiggle pierce, and what this does is it wiggles the torch back and forth ever so slightly while it's piercing. So it has a tendency to blow the slag out to the sides rather than having it blow straight back up and foul up your tips or your nozzle. But in normal cutting, leave it at normal. So once you have this all set up, you can click OK, and now you have your tool over here. So generally you go through your manual and create your tools for the most commonly used materials that you're going to be using, and you're going to be able to save your settings, so you won't have to keep looking at your manual trying to figure out what the settings are that are utilized. You know, the main things that are set by sheetcam are your kerf width. Sheetcam sets the feed rate, and it sets things like your pierce delay, your pierce height, and your cut height. The only other parameter that is not set by sheetcam is your arc voltage, and that is set in Mach. Okay, so most of the settings are saved in sheetcam and modified in sheetcam. So that's how you generate a tool for sheetcam. I recommend you go through your manual and get yourself some tools set up. Now, one side note, remember I talked about the tool number up here. The Arc Pro plasma cutters have a special feature that allows you to automatically control the torch height control from sheetcam. Normally the torch height control is either automatically on in Mach, or you manually turn it on before each cut. We talk about that in other videos and how to set that. But let's say there's a situation where I don't want to cut with torch height control for certain particular parts of my file, and then other parts I want to have the torch height control on. So one situation I might do this in is I'll open up this file here. It's being a little slow for me. Okay, So let's say, for instance, I was cutting this part out. And one particular, say this is a thick piece of steel. Say I was cutting this out of 3/16 or 5/16 steel or 3/8 steel. One thing you want to keep in mind is that when you cut holes, your plasma is trailing behind itself. So you're going to have a bevel. The top part of the hole is going to be larger than the inside of the hole. Because as the plasma cutter is moving around the hole, the flame is trailing behind itself just ever so slightly. Okay? One way you can compensate for this is by slowing down your speed on holes. To do this, I would separate this out, and we'll talk about how to do this in other videos on how to do this better. But one thing you can do